Hello everyone, we're excited to present our project, Development Stage of the Computer Revolution. This journey towards computing history shows not just where we've been, but where we're heading. The computer revolution refers to the continuous evolution of computing technology, starting as early as the 1600s. Our first stop is the mechanical era. In 1642, Blaise Pascal built the Pascaline, an early mechanical calculator. Later, Leibniz introduced a machine that could multiply and divide. But the true pioneer was Charles Babbage, who in the 1813s designed the analytical engine, the first concepts of a programmable computer. Working with him was Ada Lovelace, often considered the first computer programmer for writing algorithms for this machine. These devices didn't use electricity, only gears and levers, yet they laid the foundation for logical computation. We explored digital archives and museum exhibits to study their impact. To give more perspective, it's important to understand how visionary these early efforts were. In a world without electricity, the very idea of a thinking machine was revolutionary. These inventors laid not just mechanical foundation, but intellectual ones. They introduced the concept that machine could follow instructions and solve problems logically. This idea still defines computing today.
Fast forward to the 19th century, the second stage began, the electromechanical and the vacuum tube era. During YYI, machines like Colossus and ENIAC used vacuum tubes for lightning-fast calculation. They were massive, energy-hungry but crucial for code breaking and the military computations. The third stage brought a game changer, the transistor in 1947, followed by integrated circuits in the late 1950s. This breakthrough made computers smaller, faster, and more reliable, sparking miniaturization we still benefit from. The gauge awareness would survive students, and the 66% had heard of the term computer revolution, and the 40% were more excited about AI and the robotics. For another 40% believe society should focus on more understanding how computers evolve. This response highlights curiosity but also confusion, which is why we created this presentation to inform and inspire. Another fascinating point is that the invention of transistor and the microchip wasn't just about making computers faster, it made them available to the public. This technological leap led to the rise of startups, the Silicon Valley boom, and the start of consumer electronics. It was a spark that would eventually light path to the smartphones, laptops, and in this stage, programming languages also began to emerge. In 1957, Fortran was introduced as one of the first high-level languages. Later, in the 1960s, COBOL appeared aimed at business application. These tools allowed developers to write more complex programs in simpler ways, making computer accessible to more people. The idea of software as a product truly began here. It was also the birth of the software industry. Engineers, programmers, and analysts started forming a new type of workforce. This wasn't just a technical revolution, but a cultural shift as computers began to enter not only labs, but also business and government sectors.
Fourth and fifth stages, personal computing to the digital age. The fourth stage, the personal computers era, was a revolution for everyday life. In the 70s and 80s, companies like Apple, IBM, and Microsoft brought computers into homes, classrooms, and offices. Operating systems like DOS and Windows made technology user-friendly and accessible. The fifth and current stage is the digital and mobile era. Since the late 1990s, we've seen the rise of the internet, smartphones, and cloud computing. Today, data lives online. Devices are smarter, more connected, and increasingly powered by AI. This very project, made with tools like Canva and Google Forms, is a product of that transformation. Creating, collaborating, and presenting digitally is now second nature, thanks to decades of progress. We should also highlight how the internet transformed communication. Email replaced letters, social media connected the world, and now even education is digital. The COVID-19 pandemic proved how crucial digital tools have become, and with artificial intelligence now helping us write, design, and even think, We've entered a stage where technology is not just a tool, it's a partner. With the rise of the internet, we also saw the birth of a digital economy. Companies like Google, Amazon, and Facebook didn't just offer services. They created entire ecosystems, new jobs emerged. Content creators, data analysts, UX designers, and mobile app developers. Even students started coding and sharing their work online. We also live in the age of big data. Companies collect and analyze massive amounts of information to improve decisions, recommend content, and predict behavior. Artificial intelligence is no longer science fiction. It's already helping us navigate traffic, translate languages, and even detect emotions.
To sum up, the computer revolution has evolved through 5 major stages: mechanical beginnings, vacuum tube innovation, transistor and the microchip evolution, personal computing, digital and mobile integration. From mechanical gears to intelligent machines, computers continue to shape our world. Our survey shows that many students are eager to understand this evolution, especially as AI and robotics become more central to our lives.
As we look beyond the current digital and mobile era, many experts believe we are entering a 6th stage of the computer revolution, one driven by quantum computing, advanced artificial intelligence, and human-machine integration. Quantum computers, unlike traditional ones, don't just use bits, they use qubits, which can represent multiple states at once. They allow them to solve problems that are currently impossible for even the fastest supercomputers. For example, they could help scientists simulate molecules in seconds, leading to breakthroughs in medicine, climate solution, and material science. Artificial intelligence is also rapidly evolving. We're moving beyond chatbots and recommendation engines into AI systems that can generate images, music, codes, even ideas. This raises a big question. How will creativity change? What role will humans play when machines can think? Another trend is brain-computer interface, technologies that allow people to control computer using their thoughts. Companies like Neuralink are working on implants that could help people with disabilities or even connect the brain directly to the internet. So in short, the computer revolution isn't slowing down, it's accelerating. And our generation won't just witness it, we'll help share it.
And that blueprint keeps growing. Experts believe we're on the edge of a 6th stage, the rise of quantum computing and advanced AI. This could change everything, from medicine and climate science to creativity and education. As future professionals, we're not just observers of the revolution, we are participants. Our choices, skills, and values will shape what comes next. It's important to remember the computer revolution is not only about machines. It's about people, creativity, and responsibility. Each new stage brings new challenges and questions. What kind of technologies do we want? How will we use it? And how can we make sure it helps society, not harms it? Some of us may one day build the next great invention. Others might work in cybersecurity, healthcare, or education. Whatever our path, we are already part of this digital journey. The choices we make today will shape tomorrow's world.
Thank you for watching. The computer revolution is not just history, it's the blueprint of our future.